Hi friends, very good morning, good afternoon or good evening depending upon your place. Welcome to my YouTube channel Tech Guru Srinath. So do you know about what are the four pillars of object-oriented programming? In case if you don't know, here are them. One is inheritance, polymorphism, encapsulation and data abstraction. Today I would like to talk about polymorphism. So what is this polymorphism? As the name indicates, the same thing existing in multiple forms. So in object-oriented terminology, what we can say is a function here will be having the same function, but what function it's going to execute, whether it's a compile time or runtime, we call it maybe different because this is a polymorphism. So depending upon when actually this the binding between function name and function definition happens, we have two types of polymorphism. One happens during the compile time, that's called compile time polymorphism. The other one happens during the runtime, we call it runtime polymorphism. So now you might have wondered what is this, what is how they are related to function overloading and function overriding. Let's dive into this. The compile time polymorphism is also called as function overloading. On the other hand, this dynamic polymorphism is also called as function overriding. In other words, we use the concept of function overriding in dynamic polymorphism. Now let's understand in detail. Now let's start with function overloading. So what is this function overloading? See, this word itself contains one word called overloading. It means something extra. So what it means is we already have some system and we want to have additional functionality. For that one, we overload existing function. So in overloading function, what happens is we will be introducing new API wherein the name of the API remains as an existing API, but the type of arguments or the number of arguments, it varies according to our requirement. So this here, the binding between the function name and the function definition happens during compile time. So we call it as a compile time polymorphism. Let's take an example. Now I will take an example of logging. I believe everybody, all of you know about logging. Whenever we develop applications, generally we log because we want to debug, right? If any issues reported at later point of time, we should be able to know what's happening inside the system. That is why we have logging mechanism. So assume here we have a logging API we call print. Inside the print, we are getting parameter called data. That is basically what we are supposed to print, and another parameter, say line number. So we are actually the particular log corresponds to. So now, if there is a requirement, so now assume we got new requirement saying that we should be able to display log based on log level. We should be able to display corresponding logs. So for that one, we are okay to receive new parameter, that is log level. So here, what we are doing is we are having additional API, that is whatever the API which already existing, that is print API. For that one, we will be introducing new parameters that is called log level. So this is the concept of overloading. So here in this scenario, we are overloading print functionality with the new parameter called log level. I hope it's clear now what is function overloading. Alright, I have included IOStream because I will be using the indel directive as well as the cout for printing output on the console. Let's have a class. The class name is logger, and in logger let me have all the public members. In the logger class, the constructor I make it as a default constructor because message, and along with the message what we can have is probably you can have line number. So line number can be unsigned int. So I will use size underscore t. Line number, you can call this line number. And here I'm going to print the line numbers as well. So usually line numbers are printed along the file name at the beginning itself. So let me print this. What I can do, line number, right? So here line number we can print. Usually it will be file name and line number. So I don't have any file name, so simply I put file name, say blah blah whatever, and then line number we can. File name is this, and we can have line number here. line number is equal to here. So here we can have line number, parameter, whatever you are getting here, right? So now we can have actual message. Say message is equal to, I'm going to print the message. Let's have end of the line. All right, so we can do it. All right, now we already overloaded actually. See, the function name remains same, and the parameters, number of parameters remains changes. So also we can have additional parameters like probably log level as well, like I have explained in the theory. Yeah, let's have that as well. Another function is function overloading. What I do, just to save the time, I will copy paste the same function. I'll be adding additional parameter here. Since the log levels are limited numbers, I'm going to use integer number, or I can use start as well actually. Log level. So log level generally how it happens is, so if the log level if the log level is zero, then we can print just plain log. If the log level is zero, you can simply print the message. So whatever we have here, right, you can simply print this message. Right. Otherwise, if the log level is 1, we can print the second version of the message, whatever we have in this. So we have a message and we have a line number, we have a message, line number we have. Okay, and now we also can have log level as well actually. So log level usually comes here itself. So before file, say generally it will display like warning or on. I'll put like this, log level. Log level is equal to I can have log level variable name, and then we have log level, we have file name, and we have line number and the message. All these three things will be printed. Okay, so this is the example of function overloading. So now I'm going to put semicolon. Let's have main function. The basically driver function. The main function is one which is called the operating system. I hope you all know. Right. Now I'm going to instantiate log level, logger class. Okay, logger class example log. I can put simply log and log dot print. If we print a log dot print, then I call my app. So this will get printed. Now I'm going to put log dot print my app along with my app. What we can pass is line number. Line number, say example hypothesis 29, some random number. Another one is log. You can put this log print. So I use my app only. My app. Say example 35, 34, and we can put log level as say example 2. We can put. All right. So what I'm trying to explain is here we are exhibiting comparative polymorphism. The function name remains same. The print function name remains same. The return type also the same. The only thing is the parameters, the number of parameters and type of parameters. Because here we are having only message parameter, the string parameter. In the second overload function, we are adding additional parameter line number. In the third overload function, we are introducing log level. So based on that, we have corresponding implementation. But basic function remains same. Everything is printing. So this is known as comparative polymorphism. Let's run this code. All right. So initially, what we did is we are having three versions of print statement. So all the function print got overloaded. So initially with one parameter, second with the two parameters, and third one is the three parameters. So here you can see the message is my app. The first whenever we execute this print function with this particular statement, we are printing only message. Fine. Then we are printing message along with the line number. And then third one is we are printing along with the log level. Okay. I hope it makes sense to all of you. So what is this function overloading? Now let's move into function overriding. Okay, now let's dive into function overriding. In function overriding, there's a word called override. What it means is we already have some system. and we want to replace the existing function with a new function. So that is called overriding. So what is this function overriding means? We already have an API which performs certain tasks. Now we want to have new functionality by overriding the existing functionality. That is called function overriding. Now you might have asked how we can achieve this one. This can be achieved. See, first of all, overriding happens only if we have base class and derived class. In base class, if we developing base class, if we have intention, let the derived class implement this function, then we make the base class as a virtual. In the derived class, we are going to use the keyword called override that indicates that that particular derived class is getting overridden. So one thing we have to notice is the function signature, whatever the function name, function return type, and the parameters, everything, all these things must be identical in both base class and derived class. Okay, another thing I want to highlight is the function name, the resolution of the function name and the function definition will happen during runtime. So that's why it's called runtime polymorphism. Okay, now let's understand function overriding with an example. Assume we already have connect class. So connect class, what the connect class will do is it initiates connection with an agent that is a remote network agent. So now we want to have another class called TCP class. This TCP class must be able to connect to remote agent, but with its own parameters. So for that one, what we can do is we already have a connect class and we derive TCP class from connect class. And let's have same API, that is connect API, with all the signatures remain same, but inside connected API, we can have TCP connection logic. I hope it makes sense to you. What is function overriding? Now we know what is function overloading. What is function overriding? Now let's practice some examples.
All right, I have okay. All right, we have a IO stream and the main function. And then now I'm going to take the same example which I have explained in the theory. That is the connection class, and then in the derived class function, I will be overriding API of the base class, that is connect function. Let's dive into this. So now I'm going to have the class followed as a connect, and then connect let me have a semicolon of class. And public member is all the public members. Let's have a default constructor. So constructor is here. Constructor will be name of the function itself. I'm going to use default constructor. That's why I'm going to declare the default. Now I'll have connect function. So in the connect function, I want it to be overridden in the derived class. That's why I'm making this virtual. So virtual void and then connect function. And here let's have base plus implementation. In the base class, what I do, I'm going to print actually. I'm in a connect function of base class. Connect function of base class. Then I'm going to have a delta function. Now in the derived class, what we do, let me have derived class function. As I call it as a TCP, and TCP must be derived. I mean, is derived from connect function. In the connect function, I'm going to make a public function, public member. In the public member, I put CP. So here, let's make constructor as a default. Now I'm going to have a connect function here. So here, this connect function must be overridden. So that's why I'm going to use the override keyword. So here we can have anything actually. In practice, we are going to pile up data like IP address, port number, and agent information, all authentication information. Everything will be dumped here, and then then they generally call the network API connect. Okay. So now here, since I'm giving demo for only for function overriding, I'm just simply print some print statement. Okay. What do you see out? The cout function is called derived class. I just called derived class. Connect. Derived class I used it. All right. Now, what is enter directive? Right now, I'm going to invoke base class function. So I'm going to invoke mirror class function from the base class pointer. Because we are going to have a TCP class here. Now I'm going to call the connect function. Now let's run this code. Let's check if any error is present. We have class connect, and we are all of them are public members. We are making constructors at default, and we are having virtual keyword. We are asking derived class to re-implement this function connect. We'll have print statement here. Okay, and then derived class we are deriving from public member of connect class, and here we have a default constructor, and we are here we are overriding. That's why I'm using the word keyword for override, and it's I'm instantiating this class. So I'm going to run this now. Let's run. All right. So this is the output which we got expected. Here we can see the derived class function TCP got executed. Okay, that's what we can see in the console. All right, that's about the practice. All right, now I hope you enjoyed coding both function overloading and function overriding. Before concluding this session, I am going to summarize what is the difference between function overloading and function overriding. Now, as per the definition, function overloading meant for adding some additional functionality. On the other hand, function overriding meant for replacing the existing functionality with custom functionality. Syntactical wise, function overloading, function overloading, function's name remains same, but the parameters, the number of parameters and type of parameters can change. On the other hand, in function overriding, all the function signature, that is return type, function name, and function parameters, and type of parameters and number of parameters must be remain same. In case of function overloading, we no need to use virtual keyword or override keyword. On the other hand, if we want to achieve function overriding, we must use the keyword virtual and override keywords. And now I want to tell about one important thing, that is binding. In case of function overloading, binding between function and the function definitions happens during compile time. On the other hand, in case of function overriding, the binding between function name and function definition happens during runtime. So in case of function overloading, we call it as a compile time polymorphism or static binding. On the other hand, the function overriding, we call it as a dynamic polymorphism or dynamic binding. Yeah, regarding the scope is concerned, function overloading can be achieved within a class itself. On the other hand, for achieving function overriding, we must need both base class and derived class. Thanks for watching this video. I hope it makes sense to you. I request you to practice examples a couple more times and identify in your project where actually you have used or where actually you are going to use these function overloading and function overriding concepts. During the next video, I'll be coming with new topics. Until then, see you. Bye-bye.